Okay, sorry for the interruption. That was school calling. So, yep, that doesn't happen very often, but just in case something's gone awry, you answer. Um, Here's what we were up to. I was just saying that time explains the price and is independent of the price. Time is independent. It just does its thing. And this price, you need, in order to know, uh, you needed to know what year it was, because through time, that price was changing. So that means that the price depends on the time and or is a response to time going on. Okay. Um, so how many prices are there in 2010? Okay, so this question, it's really kind of brought on by this, and it's really asking the question, did the price continually change? Like, so did it change little by little or continuously? Um, and in my opinion, probably. So I would likely answer yes, but that is an opinion and a probably. Um, it's my opinion that usually they don't do a big jump, but they just kind of gradually change through the year. So how many prices are there in 2010? If yes, then there are infinitely many. Because it's a sliding scale. If you're saying no, that it's jumping, then how many prices are there for 2010? Just one price. Okay. So now let's look at what an ordered pair is. An ordered pair is a coupling of, but not a coupling of people, a coupling that work together. It's a couple of values that correspond to each other. So that correspond with each other. I correspond with you, you correspond with me. We are a coupling, an ordered pair. And it is written, okay, parenthesis, the explanatory variable or independent variable, followed by the responding amount. I was going to write responding, but response variable is its name, parenthesis, or the dependent. So tell me what year it is, then I can tell you what price it is. Okay, so that's an ordered pair written with parentheses separated by a comma where it says the independent thing and then the dependent thing or the response. So let's look back at the same example we just did here with the price of a chip and go forward with it. Using example 2, write the time since 2008 and the chip's price as corresponding ordered pairs. Okay, so if I look up here, 0 corresponds or is coupled with price 2. So my first ordered pair could look like 0, 2, where this is the time since 2008 and this is the price. But then 1 year later, the price was 7. So 1 year after 2008. So when I look at this, I'm like, oh, in 2009, the price was $7. Yeah. 2 years after, it was $12. Another coupling or pair that correspond to each other is 3 years later, it was $17. And we could just keep going. 4 years later, it was $22. Okay, and they correspond to each other. Tell me how much time has gone, and I'll tell you the price. What does the ordered pair 1052 mean in the context of this problem? Well, this is tell me the year, and this, I'll give you the price. Okay, so 10 years have gone by. So 2008 plus 10 years, 2018. In 2018, the price of the chip was $52. There we go. So it's really about recognizing how to read those two numbers that correspond to each other. Does the ordered pair 310 work in the context of this problem? Let's see. 3 years after 2008 was 2011. In 2011, the price of the chip was $10? No. In 2011, the price of the chip was $17. So does this ordered pair work in this context? No. It should have been $17. Mwah, mwah. Okay, does the ordered pair 310 satisfy the equation? Ooh, what was our equation again? So going back to example 2, here it is. Price equals 2 plus $5 added t times. So P equals 2 plus 5 added for t many years. Price 10. Does that equal question mark? 2 plus 5 after 3 years. So I'm just being very careful to recognize that this is the time and that is the price and put them where they belong. Well, let's compute this. 2 plus 5 times 3 is 2 plus 15 is $17. No. 10 does not equal 17, which is similar to what we saw here. So I wanted you to see that this equation, you could use the table, which is what I did just right off the bat, or you could use the equation to say whether or not it works in the context. And that is the same as saying, does it satisfy the equation? Use your calculator to graph your equation. What do you put into Y1? Okay, let me show you. So here we go. I'm going to turn my calculator on. I don't need any of that. I'm going to go to Y equals because it doesn't have a P equals. So right off the bat, I need to make some choices here. So P equals 2 plus 5 times how many years have gone by. P for price. Well, they don't exactly have P's and T's as you see on this calculator. So you really have to change this to a Y1 or a Y. And you have to change this other variable to notice how they have an X, a tau, a theta, and nu. And so we are going to change it to an X for the calculator. So in Y1, so press Y equals, and then we will press, let's see, 2 plus 5 times, and now X is right here under mode. Okay, enter. All right, got it. But now we need to graph this. So when I graph, I usually like to start in standard. So I'm going to go to zoom and go down to standard size of a graph and hit enter. Voila. Okay, so I'm going to copy that. No, that's too bright over there. Let me copy that down. Okay, so a couple of things. I want to label. I really think labels are one of the most important things that you can put in here. So this is price in dollars, and this is years since 2008. And what I want you to see is that the explanatory goes here, the independent here, and the dependent goes on the vertical. So this is time, and this is the price. Okay, and our equations graph It went up to 1, 2, and it hit. So notice it goes right there. Yeah. And does this thing where it keeps going up and up and up. So I'm just going to do a quick rough sketch of it going up and up and up and creating this graph, this image. And now when I look at that, I'm like, ooh, now that looks like a line. Hence the name of this section. Okay, so in the next video, we will talk about satisfying an equation, solutions to equations, things of that nature.